The Artemis project was supposed to mark humanity's return to the moon, but today it's more evident than ever that what should have been a clear, ambitious, and achievable program has turned into a chaotic mess of delays, unresolved problems, and industrial compromises. At this point, Artemis risks no longer representing the promise of a solid space future, but rather revealing itself as an admission of worrying managerial incompetence, which will mean, among other things, losing the empathetic support of most citizens and major media outlets with disastrous results. Am I exaggerating? Maybe. But if you'll stick with us, I will explain what our concerns are based on. That's right, folks. It was supposed to be humanity's triumphant return to the moon after more than 50 years. But more importantly, a fresh start. A project that would mark a clean break from the past. No longer a fleeting visit, a flag planted, and a symbolic race like Apollo, but the beginning of a stable, sustainable, repeatable presence. A permanent base, a platform to push toward Mars and beyond. The project, if you remember, kicked off in 2017 with an apparently clear and linear timeline. Artemis 1, an uncrewed mission, would test the system. Artemis 2 would bring a crew beyond low Earth orbit for the first time since 1972. Artemis 3 would then see humans return to the lunar surface. And all of this was supposed to happen within the 2024 to 2025 timeframe. These weren't just optimistic predictions, but solemn public commitments. A clear message. The technology is ready. The experience is there. All that's missing is political will. Too bad that will soon collide with a far less accommodating reality. At the heart of it all is the Space Launch System, or SLS, the most powerful rocket ever built by NASA. A direct descendant of the space shuttle in many ways, but it's an inheritance that weighs like a millstone. The SLS wasn't born as an economical or reusable rocket. It wasn't designed for operational flexibility or quick turnaround times. It's an industrial and political project, built to keep alive a network of suppliers scattered across dozens of American states, guaranteeing jobs and political support. An understandable choice in terms of domestic politics, but one with serious technical and operational consequences. Each SLS launch is a unique event, almost artisanal, where every detail can become a massive problem. The costs are astronomical. Every mistake is paid for in years of delays and billions wasted. Alongside the SLS is the Orion capsule, designed to carry astronauts into deep space and bring them home safely. SLS and Orion were supposed to be the mature and secure heart of Artemis, but the reality of testing tells quite a different story. Artemis 1, the uncrewed mission, was presented as a success. Orion reached lunar orbit and made it back. But behind the curtain, problems were plentiful. Last-minute postponements, aborted attempts, liquid hydrogen leaks during fueling were all signals of a fragile system with little tolerance for the unexpected. Liquid hydrogen is notoriously difficult to handle, but anyone designing a rocket for human flight should have anticipated every possible critical issue. Instead, these leaks kept repeating, like a ghost that won't go away. Enjoy deep, fact-checked space stories. Hit subscribe and activate the notification bell. Otherwise, YouTube will not show you the next videos, and you'll miss what we uncover next. The most disturbing alarm bell came from analyzing Orion's heat shield after re-entry. The ablative material, which should protect the capsule from extreme temperatures during atmospheric re-entry, showed cracks and detachments not predicted by the models. NASA tried to downplay it, emphasizing that safety margins weren't exceeded, but the fact remains, nobody had anticipated this type of behavior. If the uncrewed mission shows these vulnerabilities, how can we think about putting human lives in that system? These technical problems have effectively frozen Artemis 2, the crewed mission originally scheduled for 2024, then pushed to late 2025, and now, after the postponement of the February 6th launch, awaiting a definitive date that seems to keep getting farther away. Each new prediction arrives cautiously. Each delay is justified as responsible prudence, but behind the scenes, there's a growing climate of frustration. As if that weren't enough, during the most recent tests with the rocket fully fueled, hydrogen leaks reappeared in the same critical points, a signal that the system hasn't yet achieved the technological maturity necessary for human flight. The official narrative insists on safety first, but the truth is that a system that keeps failing at the same points cannot be considered safe. It's a question of basics, of shaky foundations that risk collapsing under the weight of ambition. Artemis 3, the mission that was supposed to return human beings to the moon, is perhaps the most nebulous and problematic part of the project. Originally at the center of the narrative, today it's like a ghost you can barely make out. The lunar lander, assigned to the human landing system developed by SpaceX with its Starship, represents a gigantic gamble. Starship is an unprecedented vehicle, enormous and complex, never before used for crewed missions. To function, it requires an impeccable logistics chain in Earth orbit. Every delay in testing, every technical problem with Starship directly impacts Artemis 3, adding uncertainty upon uncertainty. In fact, NASA has stopped talking about precise dates and has taken refuge in vague and cautious formulas, a prudent language that only feeds the impression of a project without clear direction. Artemis 3 is no longer the landing mission, but a continuous work in progress, constantly revised, with alternative scenarios often omitted from public view. When a space program stops clearly defining its main objective, it means something fundamental has broken. Behind this crisis lies a deeper problem that goes beyond technology. Artemis is a political project, a mosaic of compromises, industrial interests, and symbolic pressures that have paralyzed its progress. It was built to satisfy many different actors, but this meant losing agility and decision-making capacity. Costs have exploded. We're now talking about tens of billions of dollars spent and growing. And each SLS launch is perceived as unsustainable. Not just because of the numbers, but because of the rocket's very philosophy, a system born old, anchored to contract distribution logic rather than operational efficiency. It's no coincidence that even external oversight bodies like the Government Accountability Office and the Office of Inspector General have launched increasingly severe warnings denouncing optimistic planning, unrealistic cost estimates, and risk management that constantly shifts problems rather than solving them. Artemis isn't simply delayed. It's trapped in a model that produces delays as an inevitable consequence. Every dependency on elements that aren't ready, every revision generates new interdependencies, and the result is a slow, opaque, and fragile decision-making chain. The most bitter aspect of this situation is that Artemis is often defended as the only possible way to guarantee astronaut safety. But safety isn't just technical prudence, it's also system architecture. A program that accumulates complexity, delays, and dependencies is actually riskier because each point of vulnerability multiplies. Each postponement isn't just time gained, but an accumulation of pressure and compromises that make it harder to correct fundamental errors. Artemis, too big to be rethought, too fragile to move forward without shocks, floats suspended in a precarious limbo. NASA's public communication about Artemis has taken an increasingly defensive turn, talking about lessons learned, prudence, and progress, but avoiding the crucial question: is Artemis, as it stands today, really the best path to return to the moon? Or is it just the politically most convenient choice to avoid admitting that some initial decisions were wrong? The greatest risk is that when we finally manage to return to the moon, it will be with a fragile, expensive, and diluted program. A muted triumph, almost a formality. The comparison with Apollo becomes inevitable and merciless. Apollo had clear objectives, a precise date, strong political and scientific motivation. Artemis has many objectives, 1,000 justifications, and no truly binding deadline. It's the difference between a project that runs and one that drags itself along. While we talk about Mars, colonization, and the future, Artemis remains stuck on its first step. Returning to the moon, which should be within reach of modern technology, has become a gigantic problem, a symbol of a deeper crisis. It's not just a technical difficulty, but a crisis of method, of governance, and of the ability to transform immense resources into concrete results. Behind the scenes of Artemis, there are dynamics that rarely emerge in the public narrative, but which are fundamental to understanding the real scope of the problem. NASA isn't just any agency. It's the very symbol of American technological excellence, a colossus with immense resources, an apparatus that managed to conquer the moon 50 years ago with technologies infinitely more limited than today's. Yet that success now seems distant, almost unrepeatable. How is this possible? The answer isn't simple, but must be sought in a tangle of factors that go well beyond pure engineering. The first factor is political. Artemis wasn't born as a technical project, but as a political compromise, a mosaic of interests that saw NASA bend to consensus logic and maintenance of industrial balances. The SLS, the giant that should carry astronauts to lunar orbit, is the perfect synthesis of this dynamic. An expensive rocket, slow to build, non-reusable, designed to distribute work orders to dozens of companies across the country. A choice that makes sense for maintaining a widespread space industry and domestic political consensus, but which comes at a very high price in terms of efficiency and reliability. The second factor is technological. The complexity of the Artemis system isn't just a matter of numbers or engineering, but of fragile interdependencies that drag each other down. The problems with liquid hydrogen are emblematic. An extremely efficient fuel, but also extremely difficult to manage, which caused delays already in the space shuttle era and continues today to represent an unresolved technical challenge. Every leak, every anomaly isn't a technical detail, but a signal of a system that hasn't yet reached maturity. The third factor is economic. Artemis is one of the most expensive space programs in history, with a budget that has well exceeded $30 billion and continues to grow. Each SLS launch costs several $100 million, a figure that makes the originally planned flight frequency unsustainable. In a world where other agencies, like SpaceX or Blue Origin, are betting on reusable rockets and leaner economic models, Artemis seems like a dinosaur anchored to a past that's not coming back. This extremely high cost translates into constant pressure on timelines and results, but paradoxically, also into a rigidity that prevents radically rethinking the project. The fear of losing political and industrial consensus blocks bold choices. Artemis thus becomes a self-sustaining program, a narrative machine that must justify its own existence at every step, transforming every problem into a demonstration of seriousness and prudence, never into a fundamental error. It's a dynamic that creates a vicious circle that's difficult to break. And while Artemis struggles, the global landscape is rapidly transforming. China, with a more centralized approach and less constrained by internal consensus logic, is moving swiftly toward its own lunar program. Less noisy, perhaps less fascinating in images, but precise in its roadmap, with clear objectives and defined deadlines. It's planning a human landing by the end of the decade and the construction of an international lunar base, a plan that could change the geopolitical balances in space. The final risk is arriving late and poorly. A return to the moon, after years of delays, with a fragile and extremely expensive system, risks being a muted triumph, almost a duty rather than a victory. The comparison with Apollo is inevitable. Back then, there were clear objectives, a precise date, strong motivation. Now there are blurred objectives, 1,000 justifications, and no binding deadline. It's the difference between a project that runs and one that drags itself along. Maybe Artemis will make it, sooner or later. But the question won't just be, did we make it? But rather, at what cost and under what conditions? A return to the moon, drained of momentum, suffocated by delays and compromises, says more about our inability to decide than about our desire to explore. The moon, from a symbol of the future, thus becomes a cruel mirror. It doesn't reflect our dreams, but our limits. While NASA struggles with delays and budget overruns, China is quietly building something remarkable on the moon. A permanent lunar base. No compromises, no political gridlock, just execution. Watch our video on what China is really building on the moon to see how the space race is being redefined right now.